Ever wondered how your phone can recognize a yoga pose in a video or detect a sports move in real time? It's all thanks to some pretty clever AI techniques. Today, we're diving into a cutting-edge approach called knowledge distillation that's making video action recognition faster, smarter, and more efficient. Let's break it down. So, the big challenge here is human action recognition, figuring out what someone is doing in a video. Think of a video as a sequence of frames, right? Each frame has visual details, like body posture or objects, and the timing of those actions matters too. It's like trying to understand a dance routine from a series of still photos, and the order they're played in. But here's the problem. Traditional AI models for this are super complex. They need massive computing power, which makes them hard to use on phones or smart devices. That's where knowledge distillation comes in. Imagine a teacher model, like a super smart AI that's been trained on tons of data. It's powerful but slow. Now a student model, smaller, faster, and easier to run on everyday devices. The idea is to teach the student everything the teacher knows, but in a way that's lightweight. How does this work? Well, the teacher model doesn't just share simple answers, like this is a jump or that's a punch. Instead, it gives soft labels, probabilities that show how confident it is in each possible action. For example, it might say, I'm 80% sure this is a jump, 15% sure it's a kick, and 5% unsure. The student learns from these nuanced guesses, not just black and white answers. This process is like a student learning from a teacher's detailed notes, instead of just the final exam answers. It's more efficient and helps the student generalize better to new videos. Plus, the student model doesn't sacrifice accuracy. It's almost as good as the teacher, but way faster. Now, the real magic happens with spatio-temporal focal modulation. Let's unpack that. Spatio-temporal means both space and time. So the model has to understand what's happening in each frame spatial, and how those frames connect over time temporal. Think of it like watching a movie. You need to know what's in each scene and how the scenes flow together. The researchers used a technique called focal modulation to focus on the most important parts of the video. It's like a spotlight that highlights key details, whether it's a person's hand movement in a frame or the sequence of actions across multiple frames. This allows the model to prioritize critical information, improving both speed and accuracy. But how do these models actually learn? Let's look at a real-world test. Researchers trained a model on the UCF1 dataset, a library of 101 everyday actions, like clapping, dancing, or riding a bike. They trained the model for 60, 80, 100, and 120 epochs, which is just a fancy way of saying full passes through the data. The results. As training time increased, accuracy went up. The model's top guess, top 1 accuracy, jumped from 85% to 88.5%, and its top 5 guesses, top 5 accuracy, soared from 92.8% to 96.1%. But here's the twist, the gains got smaller over time. The biggest improvement came between 60 and 80 epochs, 6%, then just 1.4% and 0.6% after that. This diminishing returns effect is key. It's like studying for a test. You get the most out of the first few hours, but cramming for 10 hours might not even boost your score much. And here's where things get really interesting. The researchers compared their model, DVFL-Net, to others. While other models needed way more training time to reach similar accuracy, DVFL-Net achieved strong results faster. It's like an underdog athlete who trains smarter, not longer. This efficiency could revolutionize real-world applications, from smart cameras that detect threats in real time to fitness apps that analyze your workout form without slowing down. So what does this mean for the future of AI? It's a reminder that more isn't always better. By optimizing how models learn, researchers are making AI faster, cheaper, and more accessible. And as datasets grow and techniques evolve, the next big breakthrough could be just around the corner. Next time you see AI recognizing a movement or filtering through video data, remember, it's the result of smart training, not just brute force. Thanks for watching. Drop a comment if you're curious about how AI learns or what's next in the world of machine intelligence.